Imagine a cat, a simple everyday cat that you might see lounging in a sunny spot or chasing a toy. Now imagine that cat trapped inside a box. But not just any box, a sealed box that hides its contents from the outside world. But this isn't any ordinary box. And this is no ordinary cat. This box is a gateway to a realm of scientific mystery and philosophical debate. This, my friends, is the world of Schrödinger's cat, a thought experiment dreamed up by the brilliant physicist Erwin Schrödinger, a man who liked to think inside the box, literally. Schrödinger was a pioneer in the field of quantum mechanics, always pushing the boundaries of what we understand about the universe. Schrödinger's cat isn't about felines or animal cruelty. It's a metaphor, a way to explore the strange and often counterintuitive principles of quantum mechanics. It's a story designed to grapple with one of the most baffling aspects of our universe: quantum mechanics. This field of study challenges our very notions of reality. Quantum mechanics is a weird, counterintuitive world, even for physicists. It defies common sense and forces us to rethink how we perceive the world around us. It's the theory that governs the universe at the smallest scales, where energy, light and matter behave not like the solid objects we know, but like waves, probabilities and possibilities. Particles can exist in multiple states at once, and their behavior can only be described in terms of probabilities. It's a world where things can be in two places at once, where reality is more fluid than fixed. This duality is at the heart of quantum mechanics, and is what makes it so fascinating and perplexing. Schrödinger, like many of his contemporaries, was puzzled by how the strangeness of the quantum world could be reconciled with the everyday world of our experience. He sought to bridge the gap between these two realms. He wanted to illustrate the absurdity of applying quantum rules to everyday objects. By doing so, he highlighted the paradoxes and challenges that arise when we try to understand the quantum world using classical logic. And what better way to do that than with a cat? A creature that is both familiar and mysterious, much like the quantum world itself. So buckle up, dear reader. Prepare yourself for a journey that will challenge your perceptions and expand your understanding of reality. We're about to dive headfirst into the captivating, mind-bending world of Schrödinger's cat, where the boundaries of what we know are constantly being tested and redefined. Where the line between life and death is as blurry as the quantum world it seeks to explain. In this realm, nothing is certain, and everything is possible. Let's set the scene. Imagine a quiet laboratory, a place where science and mystery intertwine. Our feline protagonist is placed inside a steel box, a seemingly ordinary container with an extraordinary purpose. But this isn't any ordinary box. It's a carefully designed scientific apparatus. This box is sealed, soundproof, and completely opaque. No light or sound can penetrate its walls. Inside this box, along with our rather unfortunate feline companion, is a contraption worthy of a Bond villain. It's a high-tech setup with a sinister twist. There's a tiny bit of radioactive material so small that there's a 50-50 chance an atom will decay within an hour. This minuscule piece holds the fate of our cat. If it does decay, it triggers a mechanism. A hammer smashes a vial of deadly poison gas. The setup is as precise as it is deadly. You can guess what happens to the cat. The poor creature's life hangs in the balance. It's a morbid scenario, I know, but remember, it's all hypothetical. This thought experiment is designed to challenge our understanding of reality. No cats were harmed in the making of this thought experiment. It's purely a mental exercise. Now here's where the quantum weirdness kicks in. This is where things get truly fascinating. According to quantum mechanics, until we open the box and observe the atom, it exists in a state called superposition. This is a fundamental concept in quantum theory. This means it's both decayed and not decayed at the same time. The atom exists in two states simultaneously. It's like flipping a coin and having it land on both heads and tails simultaneously. This duality is at the heart of quantum mechanics, challenging our perception of reality. Superposition is a fundamental concept in quantum mechanics. It's the mind-bending idea that particles can exist in multiple states at once until they are observed. Imagine a spinning coin in the air. It's neither heads nor tails until it lands. Similarly, in the quantum world, particles exist in a haze of probability until we measure them. But how does this apply to our cat? Well, since the cat's fate is tied to the state of the atom, the cat inherits the atom's superposition. This means that, according to quantum mechanics, the cat is both alive and dead at the same time. It exists in a bizarre state of limbo, a feline Schrödinger's mixture. This is the crux of the paradox Schrödinger wanted to highlight. It's important to remember that Schrödinger wasn't suggesting that cats could actually be both alive and dead. He was pointing out the absurdity of applying quantum rules that govern the microscopic world, to macroscopic objects like cats. Schrödinger's thought experiment has sparked decades of debate and spawned numerous interpretations. This simple yet profound scenario has captivated the minds of physicists and philosophers alike, leading to a deeper exploration of the quantum world. Two of the most popular interpretations that have emerged from these debates are the Copenhagen interpretation and the many worlds interpretation. The Copenhagen interpretation, which is the most widely accepted view among physicists, argues that the act of observation forces the atom to choose a state, either decayed or not decayed. This means that the observer plays a crucial role in determining the outcome of a quantum event. This choice then instantly determines the cat's fate, making it either alive or dead based on the state of the atom. The very act of looking inside the box, of gaining knowledge of the system, collapses the superposition into a single reality. In other words, the observer's measurement forces the quantum system to choose one of the possible outcomes. On the other hand, the many worlds interpretation offers a more radical and mind-expanding perspective. It suggests that both possibilities, the cat being alive and the cat being dead, actually occur, but in different universes. This means that every quantum event results in a branching of the universe into multiple parallel realities. Every time we open the box, the universe splits, creating a parallel reality where the opposite outcome occurs. This leads to a constantly branching multiverse, where every possible outcome of every event is realized in some universe. It's a mind-boggling concept, implying an infinite number of universes, each representing a different outcome of every quantum event. This interpretation challenges our understanding of reality and suggests that our universe is just one of countless others. While both interpretations offer intriguing explanations for the behavior of quantum systems, the truth is, we don't have a definitive answer to the puzzle posed by Schrödinger's cat. The debate continues, with new theories and experiments constantly being proposed and tested. The mystery of quantum measurement, of how the fuzzy world of possibilities transitions into the concrete reality we experience, remains one of the biggest unsolved problems in physics. As we continue to explore the quantum realm, we may one day uncover the true nature of reality and the answers to these profound questions. Schrödinger's cat, while a powerful illustration, is still just a thought experiment. It's not a suggestion for an actual experiment, and no one is suggesting that we should be putting cats in boxes with radioactive material. The power of the thought experiment lies in its ability to make us think, to challenge our assumptions about reality. Schrödinger's cat is a reminder that the universe is much stranger than we often give it credit for. It forces us to confront the limitations of our intuition and the bizarre rules that govern the quantum realm. While we may not see cats in a superposition of alive and dead, the concept of superposition has very real and tangible consequences in our world. It's not just a theoretical curiosity confined to the realm of thought experiments. Superposition is the bedrock of many modern technologies. Quantum computers, for example, leverage superposition to perform calculations that would be impossible for even the most powerful classical computers. These machines have the potential to revolutionize fields from medicine to materials science, thanks to the bizarre and fascinating laws of the quantum world. Schrödinger's cat has transcended the confines of academic journals and lecture halls to become a cultural icon. It's a staple of popular science, appearing in TV shows, films, and books. It's a metaphor for uncertainty, for the unknown, for the strange and wonderful nature of reality itself. Schrödinger's cat has become a shorthand way to convey the mind-bending concepts of quantum mechanics to a wider audience. It's a testament to the power of a well-crafted thought experiment to capture the imagination and spark curiosity about the universe around us. So the next time you encounter Schrödinger's cat, whether in a physics textbook or a sci-fi film, take a moment to appreciate the profound questions it raises. It's a reminder that the universe is full of mysteries, and that the journey to unravel them is just as exciting as the destination.